A familiar scenario. You are taking a late-night walk home, and you pull up a digital map to find the fastest way there. The screen promises a quick 12-minute trip. What the screen doesn't tell you is that this specific route cuts directly through a poorly lit corridor where 3 assaults were reported just this week. Looking at this standard navigation interface, the system clearly displays route lines and a precise estimated time of arrival. It does not display a single contextual safety warning. The algorithm optimizes purely for speed and distance, completely blind to real-world hazard data. By following these directions without question, we unconsciously trade our personal security for the convenience of saving a few minutes. To solve this, physicist Fakhar Mushtaq designed SafePath Navigator. Rather than building a standalone map app from scratch, he structured SafePath as an intelligence layer designed to plug directly into the platforms we already use. The primary goal here is to rewrite the core directive of digital mapping. The priority shifts from calculating the fastest route to dynamically generating the safest route. Achieving this requires analyzing thousands of overlapping variables simultaneously. The solution is a multi-agent AI system, a network of specialized artificial intelligence programs working together in real time. Relying on static algorithms is no longer enough to protect people on the move. We have to utilize a collaborative AI network to map human safety. The first piece of this architecture is the threat detection agent. You can think of it as a continuous, omnidirectional radar for the user. It constantly pulls in diverse live data feeds. It monitors spot crime APIs for recent incidents, parses social media sentiment to locate civil unrest, and ingests emergency broadcasts directly from local authorities. The system identifies environmental hazards alongside human threats. By examining this NOAA satellite feed, the agent tracks storm systems and flash floods as they develop. Once the agent absorbs this chaotic mix of data, it synthesizes the information and assigns a strict confidence score to every identified hazard, categorizing them on a scale from low to critical. In a matter of milliseconds, this agent takes a highly unpredictable urban environment and translates it into a mathematically structured risk assessment. The moment that first agent flags a hazard, the route optimizer agent takes over to actively calculate a safe path around it. The system applies demographic weighting, adjusting risk tolerance based on the user. A commuter triggers a standard threshold. A solo female at night activates strict avoidance. Applying a 2.5 times safety multiplier forces the routing engine to drastically alter the path, routing away from even minor threats. The operational rule governing this agent is absolute. A route that takes 5 minutes longer but avoids a high crime area will always be selected over a faster, dangerous one. By enforcing this logic, the agent changes the routing equation, placing a higher mathematical value on human life than on travel time. Once the journey begins, the family liaison agent acts as a dedicated failsafe. It actively monitors the user's progress step by step. The agent calculates an automated check-in schedule. It dynamically sets the timing intervals based on both the estimated duration and the specific risk profile of the trip. If a check-in is missed, a 3-tier escalation protocol begins. First, a push notification hits the user's phone. If ignored, the system sends an SMS and places a phone call to emergency contacts. Finally, if the silence continues, it auto-dials emergency services, providing them with precise GPS coordinates. This protocol wraps the user in a continuous digital safety net. Even walking alone, a vulnerable traveler is never isolated or off the grid. We can see the stark difference in the user experience. Instead of a fast route crossing straight through a known hazard zone, the SafePath system safely detours around the danger, specifically routing the user past safe locations like police stations. By design, this layer is built to integrate with existing infrastructure. Utilizing a platform with the global reach of Google Maps could extend these safety protocols to millions of daily journeys, bridging the gap between basic directions and active protection. And the engineering is already there. By combining existing mapping APIs, real-time data feeds, and Google's agent development kits, this is a production-ready system today. The history of digital mapping is a story of added convenience, finding the fastest highway and avoiding the worst traffic. The next logical step in mapping software is personal safety. The shortest route should never be the riskiest. Safety must transition from an opt-in luxury to a standard, non-negotiable feature. This is why Fakhar Mushtaq is inviting Google and the broader tech community to collaborate. By integrating this safety layer, we can provide better protection for travelers every single day. Because SafePath Navigator provides direction with protection, making the world safer, one route at a time.